Hi guys, welcome back to my mathematics tutorial. Again, my name is Peter C. Dogba Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. In today's lesson, we want to continue with higher order derivative, but now we want to look at finding the third order derivative. That is, you find it the first derivative, the second derivative, and the third derivative. In the next set of videos, or in our next lesson, we'll be looking at the nth derivative of an expression. So let's look at the first problem. Question 11 says y equals to 2x squared plus 1. So to find the third derivative, you first find the first derivative, y prime. So we say 2 times 2 is 4. X, we subtract 1 from this power, gives us 1. The derivative of a constant goes to 0. Find the second derivative, y prime prime. The power here is 1. 4 times 1 is 4. You subtract 1 from this, it gives you 0. X to the 0 power is just 1. So you find the third derivative, y prime prime. Prime is just equal to 0. So this is how we find the third derivative of an expression. To question 12, y equals to 5x cubed minus 3x squared plus 10x minus 5. So again, we find the first derivative, y prime. 3 times 5 is 15. Subtract 1 from this power is 2. 2 times 3 is 6. Subtract 1 from this power is 1. Power is 1. 1 times 10 is 10. Subtract 1 from this power is 0. X to the 0 power is just 1. The derivative of a constant goes to 0. So find the second derivative, y prime prime. So 2 times 15 is 30. X raised to the first power plus, let's say minus now. The power is 1. 6 times 1 is 6. X raised to the 0 power is just 1 because you subtract 1 from this power is 0. So we find the last derivative, which is the third derivative, is 1. 1 times 30 is 30. Minus 1 is just 0. X raised to the 0 power is 1. So this is the third order derivative of these two expressions. Let's look at the third problem, which is question 13. So question 13 says r of t is equal to 3t squared plus 8t raised to the power 1 over 2 plus 1. So we find the first derivative. So we say r prime of t is equals 2 times 3 is 6. T raised to the first power plus, now we bring this 1 over 2 down. 8 times 1 over 2. T, we subtract 1 from this half, we get negative 1 over 2. Derivative of a constant goes to 0. 2 into 8 is 1 time, 2 into 8 4 times. So r prime of t is just equal to 6t plus 4t raised to the power minus 1 over 2. Find the second derivative, r prime prime of t. The derivative of 6t, 1 times 6 is 6. Subtract 1 is 0. So this is just 6 plus 4 times, we bring this power down, minus 1 over 2. T raised to the power minus 1 over 2. Then we subtract 1 from the power. So r prime prime of t is just equal to 6. Now this 2 goes into SR 1 time, 2 goes into 4 2 times, so it's minus 2. T now raised to the power 2 times 1 is 2, so it's minus 1 minus 2 all over 2. So this gives us minus 3 over 2. We find the third derivative of r. The derivative of a constant goes to 0. So this is minus 2 times minus 3 over 2. T raised to the power minus 3 over 2 minus 1. So r prime 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 of t gives us Negative, negative is positive, so it's 3t. 2 times 1 is 2, so it's minus 3 minus 2 is 5, minus 5 over 2. So we can rewrite this by reciprocating, or we say we just send it within the denominator so that this power can change to positive. So we have 3 all over t raised to the power 5 over 2. So just in case you cannot see from down here, it's just 3 all over t raised to the power 5 over 2. So let's do the second to the last problem. So question 14 says we must find the third derivative of y equals to cos of x. So we know that the derivative of cos of x is just equals to minus sine of x. That's the first derivative. So the second derivative is to differentiate this sine of x. The derivative of sine of x is positive cos of x. And then the third derivative, the derivative of cos of x is minus sine of x. So y prime 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 is equals to positive sine of x. And let's look at the next one. F of y is equals to sine of 3y. So we find the first derivative, f prime of y is equal to, now let's differentiate this trig function. The derivative of sine of an angle is just equals to cos of that angle. Then we differentiate the angle. Now the reason why we did not differentiate this angle because the angle's coefficient is just 1. The angle is just x. The derivative of x is 1. So we could even differentiate it, but it's just 1. So it won't change the problem in any other way. But now this, you have 3y. So you differentiate 3y, you get 3. So f prime of y. Now you don't multiply this value by the angle. So we say 3 cos of 3y. Now we find the second derivative, prime prime of y. We hold this 3 and differentiate cos. We get minus sine of this particular angle. Then we differentiate the angle. So what is the derivative of 3y? It's just equal to 3. So f prime prime of y gives us 3 times 3 is 9. This negative, so it's negative 9 sine of 3y. Then we find the final derivative that we were asked to find. Minus 9, we hold a constant. We differentiate sine of 3y. Sine of an angle gives us cos of that angle times the derivative of that angle. So the derivative of 3y is just 3. So what happens? F prime 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 of y is just equal to 3 times 9 is 27. And then cos of 3y. So this is how we find the third derivative of functions. And in our next lesson, we will look at how we can find the nth derivative of a function. What if you were asked to find the 1000th derivative of sine of x, the 99th derivative of cos of x, right? What if you were asked to find the 19th derivative of this function, for instance? So you must know how to go about that. So thanks ever so much for watching. See you in our next lesson. Please don't forget to subscribe. Thank you.